We're going to start by using this changing directory and working directory commands again, because they are a little bit finicky. So currently we only been using it once, I think, to get this data set. But we're going to use it again to get into our next data set, which is the one that I have been teasing, the one with personality items. And it is, so I guess I'm cheating a little bit, because I said we will be doing everything in Stata, and you see this is my Windows File Explorer window. So I guess I am cheating a little bit by using it. And then you should all have access to this data. I shared it with you, so it would be on the OneDrive. And you'll notice that most of our data are in the data folder, but the big data, the big 5 data is actually in this subfolder called big 5. So to load it, we have to make sure we are in the correct folder, which is this folder. So I can copy this here, right click somewhere in the file path, and then click copy address. I'm not sure if there's a difference between copy address as text or not. I'll try the copy address as text. And then we'll go back into Stata, and here I will write cd for change directory, and then I will enter the thing I copied. So it's important to have those apostrophes if, like here, the file path has a space in it. Because if there is a space, it will think that these are 2 entities. That's why we need to have those apostrophes. If we run this and we can double check it, we'll see that we are now in the new directory called big 5. And if we write dir, we'll see that there are 2 files here. There's a text file and there's a CSV. And we're now going to load that CSV file, and that's slightly different from how we load Stata files, because Stata knows how to use Stata files because they're made for Stata. But this is not a Stata file; it's a CSV file, so we have to actually import it. And of course, to import, we use the import command. And you'll see this is something that's very nice with Stata, is that the commands are usually the word you would assume it is. If you want to import, then it is import. If you want to save, then it is save. If you want to drop something, it's drop, and so on. But we have to say a little bit more here. We have to say, actually the way we have to write this is, we want to import delimited. And delimited is the kind of import we want to do. And delimited refers to the fact that this is a comma-separated values document. And like I said, it's not always commas that separate them. In fact, we can just take a look at this, because I think then we will see something nice. So if I can open this in Notepad, you'll see this is how it looks. So I was actually wrong. It is not, it's not comma separated here. It is tab separated. There's a tab in between all these different values. And that's why we use delimited, is because delimited says that all the values are stored in delimited ways somehow. There's a barrier between them. It's either comma, or it's tab, or it's something else. So the first part of the command is import delimited, and then we want to import or write the name of the data, which is data.csv, which is what's written here. And then I have to add the option clear. And the reason I have to keep writing option clear is because we have data in our variable list already. And I can show you why we can't just write without clear. It is because Stata is a little bit careful. It says, no, not going to do it, because if you do this, data in memory would be lost. Because I made some changes to this data set, as you can remember. And they tell me that if you do anything, if you load this, you're going to lose this. So they're being extra careful. And that's why I have to write clear here, because that will tell Stata that, yes, I know that you will delete this, but I'm fine with it. And the result is that we get 57 variables and we get 19,000 observations. And you can see the variables here. There are some background variables, and then there are this 50 other variables here, which 10 for each personality dimension, according to the big five: neuroticism, extroversion, agreeableness, conscientiousness, and openness. And each of them has 10. And notice we even got a label this time, even though the label is just essentially the same as the name. And the name and label works the same way as in SPSS. The name is a kind of a short word to refer to this variable, which is just to make it easier to program. The label is meant to be slightly longer, make it a bit more informative. You haven't seen any good examples of it here. But here would be, for instance, if age was categorized, I would probably mention that in the label to make it easier for those who came afterwards to know how the variable is operationalized. So we have this data, and what do we want to do with it? Well, you will remember, or maybe you won't because we have been saying a lot, but let's just take a look at the first variable. Again, I think it's very nice to just use tab and summarize to look at variables to get a feel for how they're coded. I know that most personality instruments are coded from 1 to 5, or at least on those 5 levels. And I also remember reading that in the text file, which I've closed now. But here we see that there are actually 6 levels, and there's one 0th level. And if you remember from the text file, and I guess I can open it again if you want to look at it, we see that they say here 0 is missed. So this 0 here means that this one person did not answer the first item of the extraversion scale. So we're dealing with missing data. And the reason why I focus on missing data is because there seems to be a lot of neglect of missing data. We don't really talk too much about it, and they are handled quite differently by different programs. For instance, if you're dealing with R, you'll probably know that R kind of ignores, or R isn't. Sometimes it seems like the people who made R doesn't know that missing data exists. So many commands will just not work if you are missing data. So you always have to kind of work around the fact that missing data exists. And if you compare this to SPSS, missing data is almost always assumed. So there's a lot of, in SPSS, they're very good at showing you how many missing there are. And Stata, again, is somewhere in between. This here isn't Stata's fault. This is the fault of the people who made the data file. But essentially, it's a problem of how do we really mark something as missing, because there's no universally agreed on sign for missing. SPSS will often save missing as -99 or -999 or some combination of 9. So you'll often find that if you import SPSS files, you'll have a lot of variables with the values -99. R will always save everything as NA, and that's a special format. And Stata will save it as dot something, just dot, that means missing. So all the programs have different ways of dealing with missing. And what we do know is that this 0 here is not going to be treated as missing. It's going to be treated as the bottom of the scale going from 0 to 5. So we have to fix that. We have to make sure that this 0 turns into a proper missing in Stata terminology. And the way we do that is simply by doing a command we learned earlier, which is replace. So I can say replace E1, and I want 0 to turn into a missing. Replace E1, 0 equals missing. And that gave me an error, invalid name. And why did that happen? Oh, sorry, because I misread my notes. So I said we would be reusing an old command. That's actually wrong. We're gonna recode instead of replace. E1, 0 equals missing. So I'm going to use a recode command instead of the replace. And then we get one change is made. And we can double check that it was correct. Tab E1 gives us now just those 5 levels. And if we can be even more specific, tab E1 and then M, this option here will allow us to also see those with missing values, i.e. the dot. And we see that there is one person here now correctly identified as missing on E1, whereas previously they were listed as having the value 0. Now the problem is that we have many variables. We have 50 variables where we have to do the same thing. And it's going to be quite tedious to do this for all variables. But luckily, there are some ways, and this is where we see that I mean, all programs have this option to do a command on many variables simultaneously. And so I'm not going to say that you can't do this in SPSS. I'm just going to say that it's maybe a bit more tedious to do it. So let's show how we do this with all the variables at the same time. So recode, and I'm just going to worry about the extraversion items just for simplicity, but we could do all variables, of course, but I'm just going to care about E1 to E10. That's the only thing I want right now. Actually, since I'm doing that, I can make it easier for you to visualize this. I'm going to say keep E1 to E10. And keep is the opposite of drop. If you're dropping something, you're specifying what you want to drop. If you're keeping something, you're dropping everything else. So I say that I want to keep E1 to E10. And now we have lost every variable apart from those 10 variables. So you don't even have to worry about those other ones. Now, we're going to make it so that we correctly, we fix those missing 0 values on the other 9 variables. So we're going to use recode again, E2 to E10, 0 equals dot. So we already fixed E1, that's why I'm not including it. And we can just, as long as we can list something, so we don't have to write every single element of the list. And I can't quite remember, but I believe that Stata will just take everything that's in between them in the variable list. But this is something you can test for yourself. But yeah, no, actually I did test it earlier, and if I had written, and let's just let's regret what I did. Let's get back the whole data set. So I'm gonna import it again. So we have this. And then I'm gonna do recode E10 to O10. 0 equals dot. So I'm actually gonna do the whole data set, even though I just said I wouldn't. But now I'm feeling very courageous, so I'm gonna do it for all of them. So I'm gonna list, oh, it should be E1 to O10. It's now gonna choose every variable from E1 to all the way down to O10. And we see we get a lot of changes made. It seems like there's one person who is missing on everything. That seems to be the problem. But now at least we have fixed it. And you see it's a very easy command. It's very simple. Very, very nice. And we can even make it, even simpler than this. But in order to do that, we have to, let's see. I'm gonna have to do something a little bit different. And that is that, let's see. Not able to do that. Okay, we'll go here. You'll see there are some buttons up here. And again, I did say we wouldn't be using any of those buttons, but I'm gonna, again, breach my own rules. I'm gonna press this one, which says, this button says, new do file editor. So far, we've been writing all our commands in the command window. But if you want to, you can write it in a separate window called a do file. And you edit the do files in the do file editor. And the benefit of this is that you can write much longer commands. You can write commands over several lines. And that's what I'm going to do now. I copied it from my other document. So you will get access to this command later. And I have to do this over several lines because it's a loop. And a loop is something other that's very fundamental alongside the if clauses. And it will loop over all of the variables that I specify, and then it will do whatever I say that it should do. And this is, I would consider this to be advanced Stata things. It is in fact so advanced that I only learned of it last week because I was doing this, I was preparing this, and I felt like, there has to be an easier way than to write all this out manually. And then I came to this. But so I've shown you a loop. Before we actually go through the loop, because I see I jumped over something I should have done earlier, let's go back to see how we do it manually. And then we can see what the benefits of the loop is. But you know what? I'm going to keep this do file because it will be helpful. So let's show how a do file works. So instead of writing stuff in the command window, I'm going to write it in the do file. This is, by the way, a comment. 2 slashes followed by a text is a comment on one line. The text turns green, so we know it's a comment. But let us just take a little bit of a look here into the code book, because if any of you have worked with personality measures before, or I mean, if you have worked with any kind of measures before, you might know that you probably know that we sometimes reverse items, right? So that we have some negatively valued items, and when we later make some scores of those, we have to be sure to reverse it again, so that we actually get a meaningful sum scale. And that is the case here. So you will see that if you look at we will just focus on the extraversion items. The first one is I am the life of the party, and the second one is I don't talk a lot. And if you read it, you'll see that every second item, every even item is negatively, or is reversed. Essentially, a high score means you're introverted, and all the odd items means that if you have a high score, you're extroverted. So what we need to do here is we need to reverse all the even items, every second item. And that's what I want to do here. That's the second change. We have the first. We have fixed it so that everyone who had a 0 value has gotten a missing value. And now we're going to change it so that we reverse every other item on the E scale. And this is when we can go back to our replace command. And we can do it very simply by typing replace E2 equals, oh, and I said I would use the do file, sorry. So we're going to do it here. E2 equals, and then I will just type 6 minus E2. And the reason I do 6 minus is, this is a very nifty way of reversing things. You just take 1 plus the highest value of the variable. So we know that this variable goes from 1 to 5. So we take 1 plus 5, and then we get 6. And then we subtract the value of the variable, or we subtract the variable from this value. We can see, if you want to make sure this actually works, we can do that. So sorry, I have to remember to be in the do file. So I'm going to do a tab E2. And now to run commands from the do file, I just have to select part of it, either all of it or part of it. And then I press Control D or Command D if you're on a Mac. And it will run it here. So we see that it goes from 1 to 5. And notice that in the first value here, we have 4,239. Then we will run this command here, which we see it made 15,000 real changes. And now I'm going to run this tab command again. And we see that now it is the 5th value that has 4,239. Previously, it was the first value. So we see that we have effectively reversed this variable. And then you have to do the same for all the other ones. Replace E4 equals 6 minus E4, and replace E6 equals 6 minus E6, and so on. And we have to do this all the way till we get to, and I'm just going to copy it because make so many mistakes when I write. So we would do this. And whenever you get this structure where you just repeated yourself a lot, that's when it's tempting to try to find a quicker way to do it, more automated. And that's usually what I try to do. And then I figure out that I spend much more time trying to do it in a quick way rather than just do it the old-fashioned slow way. And that's, of course, what happened this time as well. And that's how I came upon this loop down here. So this loop is a quicker way to do this in less text. So what happens here, what happens here is that for each variable of the variable list that consists of E2, E4, E6, E8, and E10, this thing here within the brackets will happen. It's going to use the replace command, which we know from here, and then it's going to replace the element of the list, which is one of these, with the formula 6 minus, and then the element of the list again. So again, the element of the list will be each of these in turn. And when it reaches the end of the list, i.e. E10, then it's finished. And let's see, so I did change, we already changed E2, so I'm going to just remove it from the list here. And then we will run this and we will hopefully, yeah. And then we get the result, which is that, so now we only have 4 variables and we get all these changes in each of the variables. So at this point, you might, I think this one will look a little bit intimidating the first time you see a loop. At least that's what I feel like. And this is why whenever I manage to get to this kind of complexity in coding, I will save it. And I will not only save it, but I will write a small note to myself, what does this do? And that's what I've done here. I've made a comment saying this is a loop. And what it does is that it loops over all the following variables and replaces the variable with the reverse of itself. This is what I show here is what's called a good practice, to make comments and to save this thing so I can use it later. And this is definitely going to be helpful for me if I do a lot of replacements, like here. If I ever get some personality data where I have to reverse, then I can just enter the items in here instead of writing it manually like this. So it will save me a lot of the time in the long run, even though it took me maybe a little bit too long to learn how to do it in the first place. But you know, this is, you have to do it slow the first time and then you'll save time on the long run, generally. And this is also the nice thing with me writing it into a do file, is that I can save the do file and then keep it later whenever I need it. So now we have, I think we have now fixed the E scale, and we're only going to focus on the E scale. We have removed all the missing, or we have correctly marked them as missing, and we have reversed all the even numbered items so that we can now start summing them together. And that's also something, you know, we will often do that with personality scales. We have those 10 items and we want to create a combined scale. And the way we do that is, I'm going to jump back to the command window. We're now going to use, again, generate. But we're going to do a slightly different version of it, which is called egen, or I think it means extended generate. Exactly why Stata has 2 different versions of generate, I'm not quite sure. That is to say, I read the explanation for it, and the explanation didn't really make sense to me. But I assume there is a technical explanation for why there has to be 2 versions. But what you need to know is that sometimes you need to use generate, and sometimes you need to use eGenerate or egen. Usually egen allows you to do slightly more advanced operations. So what I'm gonna do here is I'm gonna make the average, calculate a person's average score on extraversion. So I'm just gonna call it e-average, but whatever you want to call it is fine. And we set this value to be equal to the row mean, which is just the mean across a row of E10 to E1 to E10, like this. And then we get a new variable at the bottom here. And let's take a look at how it looks. And I'm just going to print it along with E1 to E10 and also E average. This is just a summarize. I'm summarizing all the E items in addition to the newly created variable. And we see down here, at least I always like to make sure that after I made a variable, it looks the way I expect it to. So here I expect it to have the same minimum and maximum as those variables, because it is just the mean of all of them. I expect it to have the same amount of observations, unless there's any missing. And I expect the mean, of course, to be the mean of this. And that seems to be the case. It's 3, and these seem to be somewhere between 2 point something and 3 point something. And the standard deviation is slightly smaller, which is not strange. So this seems to have been worked fine. Yeah, and that's how we make a summed variable. Very easy and simply. Also, again, let me show you another command that can make your life easier. So now you'll remember this is what I wrote. I wrote summarize E1 to E10 and also E average. This is all the variables I wanted to summarize. But if I was feeling even more lazy, I didn't want to write all this. What I could do is I could write E and then asterisk. And this is our wildcard. So this will essentially match anything that starts with an E. And in this data set, that's going to be E1 to E10 and also E average, because we don't have any other variables that starts with an E. So if we run this, we'll see that we get exactly this. Oh, actually, I was wrong. We did have one variable starting with an E. Not, of course, is there. So it will give us all these variables. But this is the same as we got earlier. And then this blind passenger I hadn't intended to get, but we got him as well. So this is those wildcards will be also helpful to hit a lot of variables instead of having to manually type out all of them. So here, yeah. So here I wanted to show you kind of some minutia again of what happens when we have missing. So this is we're going deeper into the missing rabbit hole. And to illustrate this, and the reason I do that is because missing is something it's been a stumbling block for me many times when I didn't realize that I was dealing with missing, and then I had some problems later down. That's why I'm focusing on it here. The problem here is that we have no missing in the dataset, or we had that one person. So I'm going to need to create some missing variables or some missing values. And the way I do that is and first, again, I'm just going to drop this because I don't want it anymore, this E average. So let's drop it. It is no longer in the dataset. And then, yeah. So what I'm going to do is, and I will just copy this again. I'm going to take this do file that we're working on, go a little bit further down, then copy this. So what I'm doing here, I'm using the replace command, and I'm saying that on the variable E3, 4, 5, 6, and 7, I want observation 11 to 100. And we have 19,000 here, so this is just a very small subset. I want these people from 11 to 100 to have missing values on these variables. So I'm replacing their E3, E4, E5, E6, E7 values with missing, only for these participants. And if we wanted to do this with a loop, it would look like this. This is just to show you that again, this is kind of similar to what we did over here. And thus it was easy for me to then just put it into a loop and then change it slightly. Instead of doing 6 minus var, I'm here doing this is equal to missing in and so on. You can, if you're interested, you can study it a bit more in the do file I will release later. So far, I'm just going to run this. And what we see is that for these 5 variables, 90 real changes were made. 90 were set to missing. So now, and let's just do the summarize E again. We'll see that we have now, on these variables, we have now 19,628 instead of 19,718. So we have now some missing values. And the reason I created these was just to illustrate what happens when we have missing. And what happens is that, yeah, so let's, you remember earlier we used the egen to create the mean of a person's scores on all the E items. So I'm going to do that again, row mean. And I'm just giving it a different name. This is because now we have missing values. So I'm just making a reminder to myself, this is the one created with missing values. It is, the value of it is set to the mean of, and again, I keep writing 10 instead of 1, E1 to E10. Only one missing value generated. That's interesting. Only one missing. We would expect there to be more, maybe 90. Let's again summarize all variables, all E variables. And we see here that this is the mean score. It has 19,718 observations. Despite all of these 5 variables, despite half of the variables having missing values. So the point I'm trying to make here is that Stata doesn't care that half the list is missing. But we as researchers, we care. We don't want to create a sum score if so many people are missing, right? Those people that have 5 items missing, they have to be set as missing on the sum scale. But Stata won't do that automatically. And most programs won't do it automatically. So we have to be wary and be on the lookout and do this manually. We have to manually tell Stata that you should not create the sum score if there are so many missing, or for those that are missing so much. And the way we do this is, it is, I think, a slightly unnecessarily complicated process. This is the one time where I felt that SPSS has an easier way to do something compared to Stata. And I'm also surprised that I have not been able to find a package that does this more easily. And I guess that means I should design it myself, but I'm not that good at programming, so I'm not going to do that. But okay, what are we doing here? And maybe, yeah, we'll do this also in the do file editor. So we'll go down a bit here. And so what we're going to do is we're going to create a variable called rm. This is equal to row miss E1 to E10. So we're creating a variable which we call rm, which is just short for row missing. And this, we use the row miss operator, which will calculate the amount of missing you have from, I mean, you can have missing on all 10 or on none of them. That's the first thing. So, and again, use comments. So make notes to yourself. How many E variables are missing for each person? That's how I remember what this thing does. Then afterwards, and let's just run it. We ran it. Then afterwards, we are going to create a variable which we already are familiar with. Egen average, or E average, equals row mean of E1 to E10. This is exactly the same command we used earlier to create the mean value, but we're going to use our knowledge of the if clauses and say that you should only create this average variable if the row mean is less than 3. Row miss is mess. The words. We are creating a new variable here called the average of E. It is the average of all the E variables, but it's only going to be calculated if you have less than 3 missing. So if you have more than 3 missing variables, then it will not be created. Let's do that. And now we see 91 missing values generated. And then afterwards, we don't really need the RM, so we can drop that. It has done its duty. And now, now let's just summarize those two. And we see that this is the one where we included all the missing, 19,718. This is the one without the missing. And we'll see, I mean, there's not much difference, of course, but there is some difference. And this is important to be thorough. So I guess my point isn't that there's not much difference, but it's easy to miss it because there's no red flags when we look at it. But you will see that there are some differences in this, and it's important to be as thorough as possible. Any questions so far to this? Then we have now gone through most of the data manipulation that I wanted to talk about. We will have some examples later of centering variables when we get to regression. But this is kind of the things that I thought were the most central when it comes to data manipulation. And the reason I wanted to show it is that there is a tendency when, like, you can learn maybe to do the analysis in Stata, but you always have to do some data manipulation. And if you can only do that in SPSS, then you end up in this very strange situation where you're doing the data manipulation in SPSS and then having to import it into Stata. Which is unideal because if you make a mistake and you have to go back to SPSS and it's you're wasting a lot of time going back and forth. So ideally you'd want to be able to do absolutely everything you can do in SPSS in Stata, and that is possible. Everything you can do in SPSS can be done in Stata, as far as I know. At least everything I wanted to do. And we have now shown how to open Stata files. We have shown how to import non-Stata files, and you may, of course, also want to save files as Stata. So we have done a lot of changes to this dataset, and that's when you might want to save it, to retain those changes. So let's just check, where are we at the moment? We're currently here in the data set and big 5. And the command to save something is very simple, save, and then the name of the dataset. So I'm going to call this big 5, big 5. And it has now been saved as a DTA file. So you'll see it here. It is now saved as a DTA file. So next time you don't have to go through the whole process of importing the CSV if you don't want to. And so, yeah, so now we have done most of the data manipulation, and what I'm thinking of doing now is showing you examples of how to do the common analysis that most people, as far as I know, do. So we'll be going through factor analysis, regression, t-tests, and structural equation modeling. I know that many people use Stata to use the structural equation modeling options, so that's why we look at that as well. Let's start with factor analysis, because we have this very good data set here, which is nice to do factor analysis on. So I'm going to do a factor analysis, and it's the command. It is as simple as you could expect. It's simply factor. And I'm not going to bother with all these items. I'm just going to do E1 to E10 and N1 to N10 and also A1 to A3. So I'm not going to do O and C. And we run it, and we get a big output here. And if you know how to do it, of course, you know how to interpret it. We see that there's 2 factors with large eigenvalues. In the case that we should extract 2 factors, we can verify this by looking at the scree plot. How do we get the scree plot? We write scree plot. And that will pop up this nice graph, which is the scree plot. Again, point of inflection is down here, indicating that the 2 factors before it should be extracted, i.e. scree plot supports the notion that 2 factors should be extracted. Which is maybe strange because after all, we put 3 scales in there. So we would maybe expect 3 scales to come out, but I guess maybe the big 5 isn't as big as we thought. To extract only 2 factors, so I'm gonna get back our factor analysis here. We should specify that we only want 2 factors. And we do that by writing in options like this. So the comma, we've been using the comma a few times. The comma means that whatever comes after is optional. So that means you never have to write this comma and everything afterwards, but it is used to augment the base command. So in order for the factor command to work, I need to write something after factor. I need to specify which variables am I going to do the analysis on. But I don't have to specify how many factors I expect to get out. So that's optional. But now I want 2. So I specify I want factors 2. And then we see only 2 factors come out of it, as I specified. And you know that the next thing we have to do is to... Actually, I see maybe now what the problem is here. What was my command? Yeah, okay, so maybe you know, so it's always important to be thorough, and you'll see that probably what's the reason why we get these only those 2 factors is because I wrote A1 to A3, should be A10. Now at least we get all the AAs. But yeah, let's you know what, we'll just keep going with 2. But we got a question from the chat, and that is if we can do parallel analysis, and that's a good question, and we can do a parallel analysis. And I believe I'm a bit rusty on factor analysis, but so we'll take a look at it. So a parallel analysis would be instead of the scree plot. And to do a parallel analysis, we need to change something with the factor analysis. And to do this, I have to take a look at the help file of factor analysis. This is a very helpful command called help. I'll write help and then the name of the factor I'm interested, or the function I'm interested in. It will bring up a help file. And this is something that's undervalued in, I think, Stata. Stata has the best help file of any program I've ever used. They have really worked to make this easy to understand. If you ever try to read something on how R code works, it's like a jungle of terms and links taking you back and forth. But in Stata, you can actually just read this and you'll get an understanding of what this function does. So we see here that this is the way we write the command. We start by writing factor, and actually we only have to write fac. We don't have to write tor. So we'll save maybe 0.3 seconds here. Then we write a list of variables, and this is, you remember we did this up here. We wrote this list of variables, and then the options are specified here. And the options are further elucidated down here. And take a look at this, what it says here on the model. So there are 4 different models we can run: PF, PCF, IPF, and ML. And it says actually here that the default is principal factor. That's the default factor analysis method, unless I specify anything. And I didn't specify anything, as you can see. I just specified the number of factors. That means that we ran a PF command naturally. This is actually the opposite of in SPSS, where unless they changed it, the default in SPSS is principal component factor, meaning PCF. And I believe if we want to do the parallel analysis, I believe we have to do the PCF instead. Because I remember that there is some you can only do the square plot on one of them and only the parallel analysis on the other one. And then after we do this, then I believe, I can't remember if it's a package or not, then at least you can get a parallel analysis from that. But I can, if you remind me, I can put it into the commands, because I have those commands saved somewhere else. Another question was, how do we get our earlier commands back? This is also a very nice feature. Just press page up or page down, then you'll get it back in the command window, and it goes back quite a while. If it says this, it means that this was a command I ran from the do file. So page up and page down. Last thing, this is again a help. So let me just run these things again here. I have to go down a bit. So we are running the factor analysis. We ran that one, and then we are, you know that you have to rotate the factors. So we're going to rotate them, which we do by writing rotate. And then here I actually have to write some options. I want this to be an oblique rotation, and I want it to be specifically a Promax rotation. And then a last option I can specify, and this is just to make the output easier. So I guess I'll run it without showing you that option. First, this is the rotated factor loadings in the pattern matrix. This is what you're going to end up looking at a lot when you do a factor analysis. If you specify the option blanks, and then I'm going to say 0.3, what this will do is it will hide all factor loadings that are below 0.3. So you can also specify 0.2 or whatever you want. And the reason I do this is if you have many factors and you're going to be spending a lot of time looking at this, you don't really care about the very low factor loadings. So you can make it easier on yourself to hide them, because you know that if the loading is very low, then it doesn't really, you don't have to care about it. Like here, for instance, A3 has low loadings on both factor 1 and 2. So it's actually invisible. So do note, they are still here. I mean, you can see them here, but they are invisible, just to make it easier to look at, easier to interpret. At least I find that to be a very helpful option. And yeah, so we have now, let's take a look at another very helpful option or command. We have cluttered our screen here with outputs from these factor analysis, lots of text. If you're very conscientious, you might not like clutter. You might like things to be neat and clean, and you might want to get rid of all this text. And you can do that by typing CLS. And now it is nice and empty. Very, very nice. But we still have something here. We don't like that. We'll just clear it. Oh, now this is dirty. Okay, CLS. And now we are very blank, a very zen moment.